So what I'd like to do now is look at an example where those three conditions don't necessarily hold, and specifically what to do if the third condition doesn't hold. I can't emphasize enough that AST is never, ever used to say that a series is divergent. It's only that if those three things are true, then the series converges. If any of those fail, you're out of luck and you got to try something else. But if number 3 fails, you can go a very specific route always. So let's think about that. So here's an example. Remember, the UNs that we're talking about are not all of this. Remember, all of this, that's what we call our terms of our series, our A sub n's. The part without the flip-flopping sign there, our U sub n's, would be that, right? Now, we're good on number 1. These are definitely positive. What about increasing or decreasing or what? Well, let's just think about this a second. As we go to infinity with this, we know from algebra that's headed to 1, but all these numbers are less than 1, right? Because the bottom number is bigger. So we've got numbers less than 1 that are heading to 1, so it must be going up. So these are actually increasing. So whereas we were good here, that is bad. And as I just mentioned, we also know that that limit when we make it proper, or not proper, what do I want to say, determinate, we get a limit of 1, which is bad, right? We wanted non-increasing, failed. We wanted this to go to 0, failed. So what next? Well, if 1 or 2 fail, we might be able to use what's called AST, which we will get to shortly. But if 3 fails, let's think about this. If the U part, so just this, is getting closer and closer and closer to 1, then putting this piece in just means that for very, very large n, this is essentially 1, negative 1, 1, negative 1, 1, negative 1. In other words, if you went very far out, you've got basically plus something that's approximately 1, plus something that's approximately negative 1, and so on. But by nth term test, we know that that would be divergent, right? Because these terms are not heading to 0. So the way I'd like you to argue this is that once you've established that this limit is 1, so you would say you really don't need to write any of this. This could be a mental check, right? Once you saw that stuff was not being satisfied, you know you're not using AST. But a quick mental check on this, you know this limit, so you might just write the limit as n goes to infinity of n over n plus 2. So this might be what you would, the details I would want to see there is that this limit, first making it determinate, that limit is 1, which is not 0. And an important thing to know is we have not done nth term test yet, right? These are not the terms of the series. They're just the U part. But if this limit's not 0, as I just argued, putting that in there, that limit is won't exist, right? Because out at infinity, it's getting closer to 1, negative 1, 1, negative 1, which is definitely not 0. Now that is nth term, because these are the actual terms of the series, and they're not heading to 0. So our series diverges by nth term test. So notice this argument has nothing to do with AST. AST essentially is here just to show you that we can't use it. Right? So this AST is no part of my argument. My argument is the UNs are not heading to 0, which means the ANs must not head anywhere. That limit doesn't exist, which is not 0. So ultimately what we're doing is an nth term test. Right? So don't say it's divergent by AST. We did nothing other than fail to use AST here. Now, there's a little bit that really needs to be shown here to be rigorous. I mean, we really didn't prove anything. That was just some hand waving on my part that these would head to 1s and negative 1s, basically. But it gets into an epsilon argument based off the definition. You really have to do a proof by contradiction. And I don't want us to get into a big, long argument just to argue this one little thing each time. So from now on, when you're looking at a series like this, really all you got to do is show me that the UNs are not heading to 0. Then you can just state that that limit must not exist then, since this is not 0. And then make your conclusion by nth term test. So remember, AST never, ever tells you divergence. It can only tell you convergence. So right here, this is all scrapped. But we did learn something useful. We learned that that limit's not 0, which allows us to go through and make an nth term argument.